With the crankshaft out of the motor, the camshaft is removed and measured along with its bearings. I can use either telescoping gauges or an inside micrometer. Both use the same technique, a learned skill, sort of wobbling the tool around. However, inside the motor, it's easiest to use the telescoping gauges, and then measure the width with a standard micrometer. The camshaft journals are measured with an outside micrometer, and it's good to have one that measures down to 10,000ths of an inch with a side vernier scale. The Navistar and Ford service manuals give the allowable ranges and the running clearances. The camshaft journals show no wear and are at the maximum diameter. The bearings are slightly over, and the combination shows the maximum running clearance. That allows for more oil volume to escape, and therefore lower oil pressure, which will only get worse over time as the parts wear. With these bearings having this amount of wear at 75,000 miles, and with the fact that these are the only OE bearings in this rebuilt motor, my gut feel is they never changed out the bearings when the motor was rebuilt. I purchased both Navistar OE and Clevite bearings. The companies use different technologies and designs. The oil inlet ports are the same width and length. Navistar uses what appears to be bronze, while Clevite uses an aluminum coating as they state in their literature. Clevite's oil channel is not as deep, but it's broader. Probably the same flow volume, but slightly less bearing surface. Not really enough to matter. The way Clevite stamps their ID on the outer diameter affects the bearing surface after final honing. Navistar's supplier also imprints the information, but it doesn't affect the bearing surface, although they have a funky means of mechanically merging the ends. It's designed to fit at the top where the bearing is not loaded. Navistar's method for removal and replacement uses pressure rather than impact. Hammer Tech was fine for the 60s. There's an engineering reason for not impacting the install. It compresses the ring and alters the diameter. Distortion, even if slight. It may be a picky point, but all the auto manufacturers have moved away from hammering them in to pressing them in. And Navistar has a tool for this. It's an expensive tool. The kit I own doesn't have the 66mm size necessary for these. Going to McMaster's site, they have washers with 66mm outer diameter. But to use these with my 3/4 inch jack screw, I needed to make up the difference between the ID and my screw, and backing washers to bridge the gap of these two. The smaller washers are about half as thick as the full diameter washers, and due to manufacturing tolerances, the OD is just a little under the ID of the large washers. So by using wire strands that are half the difference, I tied them together. I then epoxied the gaps, overthinking again. Putting aluminum duct tape over all this worked just as well. This tool setup was typical for what I've done in the past to install cam bearings. I use foam pipe insulator to protect from the jack screw threads as a precaution. The washer pack is installed at the back of the motor, ready to pull through the bearing shell. At the front, a larger plate is used as the base, and this is just all screw tech. The rod is double nutted so I can hold it from rotating while turning the other nut against the flange, pulling the bearing in. With flanged nuts, they are comfortable to hold with a socket during removal and installation. and a telescopic magnet helps to grab everything during this procedure as you work through the bearings from the rear to the front. From the rear to the front, because the bores facing the front of the motor are not chamfered, and in the rear they are, giving you a way to guide the bearing shells or tools. This was the installation setup. The main flange acts as the base against the block. Behind it is one of the 66mm assembled washer packs. It's used to center the jack screw in the bore so the force pulling the bearing is not canted. The bearing is guided into the bore with the second 66mm washer in front of it. The backing washers act as spacers. The third 66mm washer pack brings the bearing home for the last few millimeters. This is the safest way to get the bearing in proper alignment, and another flange pushes all of this. The backing washers were undersized, so I wrapped these washers with masking tape and then Velcro to bring the outer diameter just up to the bearing's inner diameter. I originally marked the blocks and shells to align the oil passages, but it was easier to mark the shells at bottom dead center and guide them that way. With each bearing install, you need to check the oil port for alignment, too far forward, too far back, and indexing. This can be done with a simple inspection mirror or a $35 borescope. And that Amazon borescope for a smartphone is a handy tool. With the existing conditions, this motor was at the broadest running clearance. But with the new Navistar bearings installed, oil pressure will slightly increase because of less internal leakage. This 2003 cam was not going to be reused, but I'll go through the normal steps. Well, in some cases you could use micrometers to measure the base circle and lobe to determine lift. That is not always possible depending on where the ramp of the lobe starts. You don't always have that 180-degree capability. But you can use a micrometer to measure for total lift and lobe wear. The manual says you can have 20 thousandths lobe wear, which is a crazy amount of wear to have. I also wanted to check the cam for straightness, so using some of my 80/20 aluminum erector set, I made up my V-block setup. And this is a better way to check for lift. Camshaft runout only showed over 1/10,000th of an inch with this high-resolution dial indicator. Neither Ford or Navistar manuals gave an indication for acceptable runout of a cam. And this 2004 to 2006 manual shows the lobe lift values for intake and exhaust. However, this is a 2003 motor, and the Ford label says it was built to 2003 specs. And these are the specs out of my 2003 Ford manual. Intake .226 and exhaust .229. Colt Cams has a table that I don't think they realize is misleading. What is shown as a stock 6.0 cam is the 2003 version. The stock 6.4 specs are what is noted in the 2004 Navistar manual for the 6.0. So I'm going to measure the cam lobes and take you on a little journey, but also watch my zeroing the dial indicator. I'm only going to do the first 4 lobes. They are exhaust, intake, intake, and exhaust from the front of the motor. I did the rest, but I won't put you through watching all of that on video. So the base circles of intake and exhaust lobes are at a different height from the cam's center line. I mentioned the Colt cams chart shows the factory cams and their offerings. Based on the cam lobe lifts, what was installed in my remanufactured motor, which was labeled as rebuilt to the original 2003 specs, appears to have the lobe profile of the unique 2003 camshaft. Its lobe separation is between the current Ford offering and the Colt Stage 1 and 2 options. A little bit hot rod, but not as good for emissions, which is probably why 2004 cam is now the only one available. 2003 motors have a reputation of strong offline performance and some black smoke on acceleration. Lobe separation is a significant factor in turbo diesel performance. The base circles of intake and exhaust lobes are different from the cam centerline, and the 0.008 difference between them would be taken up by the plunger preload of the lifters. I checked all the lobes and base circle measurements, and things get whacked. Using the very first lobe as the baseline, look how they differ. Not only intake to exhaust, but down the entire camshaft. The lobe lifts are as they should be. There was no lift variation with each lobe by machining or wear. If I add 0.008 of an inch to the base circle values of intake lobes, it gives a little better perspective of what they did. They reground the camshaft, probably trying to deal with this. Trying to salvage this camshaft. So no camshaft lift variation caused the altered pushrod movement during my valve train measurements before I pulled the motor. But the change in the base circle is a concern. This camshaft was reground, and the smaller base circle of the latter lobes may have been part of the issue with my situation. And using my straight edge on the V-blocks, there is not a distortion of my 3030 aluminum extrusion. This motor had a reground camshaft and had the shorter 6.4 push rods that are the only push rods now sold by Ford for the 6-liter. As I mentioned in the lifter inspection video, Dynamic Diesel, with its reduced base circle Stage 1 cams, states you have to install push rods of the original 6.0 length, or valve train damage can occur, or something else. The cylinder 8 lobes are at the back of the oil feed channel. It will be the last to develop full oil system status. Under the condition of being stopped with the valve opened, the oil in the expansion chamber will drain out. So during the initial motor revolutions it will be starved for oil. The lifter plunger will bottom out. With the situation of both a reduced cam lobe height and a shorter 6.4 push rod, it will take more plunger travel before the plunger bottoms on the ledge. The valves will not open as far, or possibly not at all, because the plungers are going deep into the lifter bore before being stopped on the ledges. And the combustion gas in the cylinder will not be fully blown out the exhaust valve, but will present itself as a high pressure when the intake valve is opened, and you will get blasts of air out the intake until the lifter is filled with oil and the valves fully open. No lifter failure, no cam failure, just a poorly machined and assembled motor. With the original longer length push rods, this would have not occurred with this motor, or it would have not happened if the camshaft was not poorly machined. Although without it, I probably would have had a failure of the motor from the other issues I found, possibly at another 25,000 miles. How lifters and cams may occasionally fail, and a further examination of this cam I may do in another video. Thanks for watching.